Hello coders, I welcome you all. As you know, we are working on our MLOps project called Water Potability Prediction using machine learning. We have performed various experiments to find the best model. Once we identified our best model with best hyperparameters, we created a DVC pipeline that generates the model and stores it in the MLflow model registry, which is hosted on Dockerize. However, we don't store the model directly. Instead, we have set up a CI pipeline, continuous integration pipeline, to run several tests on the model. If the model passes the test, then only we are promoting it to the production stage in the MLflow model registry, which is hosted on Dockerize. After promoting the model, we fetch it and serve it using FastAPI. This ensures that only well-tested models are deployed into production. But before deployment, there is one very important step. We put the entire application into a container to make sure it works the same way in all environments. So we will create a container for our application and deploy it. In this video, we are going to learn how we can containerize our application. To do this, first we need to learn the basics of Docker. After that, we will Dockerize our application. First, we will start with the theory. Then we will discuss some practical examples. Please listen to the theory once. All the theory will make sense when we start the practical part. So let's start with what is Docker. Docker is an open source containerization platform that allows developers to package applications into containers. A container includes everything the application needs to run, like code, runtime, libraries, and system tools. Please imagine Docker is like a magic box factory. What it does? It helps developers create boxes. These boxes are called containers for their applications. What's inside the box? Everything your application needs to run: code, libraries, system tools, and settings. Why it's special? Once the app is in the box, it works the same way no matter where you take it. Your computer, a friend's computer, or even a big server in the cloud. In short, Docker is the tool that builds and manages these boxes. Boxes means containers. So apps don't complain like this. It works on my machine, but not yours. Hope all of you are clear with this, right? Let's move on. Let's consider the scenario before the Docker was not there, right? Before Docker, developers faced it works on my machine issues like different operating systems. Your app runs on Ubuntu, but the server uses CentOS, missing dependencies. The app needs NumPy, but it is not installed on the server. Library mismatches. Your machine has NumPy 1.21, but the server has NumPy 1.91. Then you can see the result. The app crashes or behaves unpredictably, right? You can see these are the common issues faced by the developers when the Docker was not there. Now let's consider the scenario with Docker. Applications are packaged into containers called boxes, right? That include the app's code, our application code, all required dependencies, libraries like NumPy and specific versions, necessary system tools and settings, even the operating system if needed. These containers or boxes ensure the app always run in the same environment no matter where it is executed. Your laptop, a teammate's machine, a server, or in the cloud. So the result, the app works consistently and reliably everywhere. You can see the scenario with Docker. Build once, run anywhere, right? So these are the advantages of using Docker for our application deployment. Now let's move on. So now to understand Docker in better way, let's take this analogy. Please imagine this. You own a chain of restaurants and you want every restaurant to serve the exact same dish, no matter where it is located. But there are many challenges in this, right? Every restaurant has a different kitchen setup. That is obvious. So how you can be sure they will all make the same dish? Another challenge. Every chef might have slight different way of cooking. That is obvious. And they use slightly different ingredients. Another challenge, inconsistent taste. Maybe customers in one city love the dish, but in another city, they doesn't taste the same. I think you have experienced this, right? It happens many times, right? So now what's the solution? In our case, Docker. Now, instead of sending just a recipe to each restaurant, imagine you send a pre-packaged meal kit to every location. And here what's inside the kit. You send the exact same ingredients, no more, no less, to each restaurants that you can see here. No one has to guess the quantities and quality. Also, you send detailed instructions for how to cook the dish. No room for guesswork, right? The chef just follow it exactly. And also you send specific tools, means kitchen gadgets. They need to cook the dish perfectly. Hope all of you are clear with this, right? This is the exact idea behind Docker. Now, from our previous analogy, you can understand the benefits of Docker. First, consistency. Every restaurant, in our case, server, makes the same dish because they all use the same pre-packed meal kit, right? With Docker, your app runs the same way everywhere. Second, portability. You can easily send your meal kit to any restaurant and it will work the same, exactly same. Docker lets you move your app to any system without changing it. Next, speed. Pre-packed meal kits save time because chefs, in our case, servers, don't need to figure out recipes. Docker containers are ready to go, speeding up development and deployment. Next, efficiency. Only the necessary ingredients are packed, reducing waste. So Docker containers are lightweight and use fewer resources, improving performance, right? So these are the benefits of Docker. Hope you can understand, right? Let's move on. Now let's understand different components of Docker using our analogy that we have discussed earlier. First component, Docker file. Think of it as the recipe that outlines how to prepare a pre-packed meal kit. So this Docker file contains step-by-step instructions specifying the exact ingredients. In our case, code, dependencies, libraries, tools, and the process to prepare the pre-packed meal kit. So this is the first component of Docker, Docker file. Now next, Docker image. When you follow the instructions in the Docker file, you end up with a pre-packed meal kit. This is our Docker image. It is not the meal itself, but the kit that's ready to be used, right? Don't you worry, we will discuss this practically. Next, Docker container. When a restaurant, in our case server, receives the meal kit, means Docker image, they follow the instructions and prepare the meal. This active meal is now the Docker container. I am repeating, this active meal is now the Docker container. It's the running instance of the Docker image. When you are running the Docker image, it becomes Docker container. It's a running instance, right? You can compare it with program and process. So this is process. Docker container is a process, right? It's a running instance of the Docker image. As I said, when you run Docker image, it becomes Docker container. So let's summarize. The Docker image is the static packed kit and the Docker container is the live running version of the Docker image, just like a meal being cooked and served at the restaurant, right? So please remember, Docker container is the running instance of the Docker image. As I said, don't you worry, we will discuss this practically. So now let's move on to our next component of Docker, Docker registry. Think of the Docker registry as the warehouse or store where all the pre-packed meal kits are stored. Means all the Docker images are stored here at the Docker registry. It's like a central location where these kits are stored and made available for use. It contains kits developed by others as well, not only by you. You can use the kits developed by others, meaning you can use images created by others, Docker images created by others, but only those available publicly in this Docker registry. In the case of Docker, the Docker registry available on the Docker Hub. Don't you worry, we will discuss this all practically, right? I hope all of you are clear with main components of Docker. Now let's move on to our practical part. To use Docker in our project, we are going to use two main tools. First, Docker Desktop, and second, Docker Hub. So what is Docker Desktop? Docker Desktop is a user-friendly application that provides you everything you need to build and run Docker containers on your local machine. It is designed to make easy for developers to use Docker without requiring much technical setup, right? So you can see I have already installed Docker Desktop. To install Docker Desktop, you have to visit www.docker.com. Inside this products tab, you have to click Docker Desktop. And from here, you can download Docker Desktop. Download it according to your operating system, Mac, Windows or Linux, right? So once you install Docker Desktop, you will see screen something like this, right? Now what is Docker Hub? So from here, you can open Docker Hub. So Docker Hub is a cloud-based registry service where Docker users can store, share and distribute Docker images. Think of it as a central library or repository for Docker images that can be easily accessed and used by anyone, right? So as I said, to use Docker in our project, we are going to use these two main tools, Docker Desktop and Docker Hub. Hope all of you are clear with this, right? And here you can see Docker Desktop GUI. This is first tab, containers. Here we can view all running and stop containers that you can see. These many containers are available in my Docker Desktop that you can see. So you can start, stop, restart or remove containers that you can see. So as I said, from here you can start, stop, restart or remove containers as well as view containers logs and details that you can see. So this is our first tab of Docker Desktop. Second, images. So this tab shows all the Docker images available on our local machine that you can see. In my case, these many Docker images are available on my local machine. So you can pull new images, build images from Docker files and manage existing images. Remove or tag them. Don't you worry, we will discuss this all practically. Next is volumes. These volumes provide persistent storage for data that can be shared between multiple containers. Next is Docker Hub, as you can see, right? So from Docker Desktop, you can directly use Docker Hub, right? Also, as I showed you, as a web app, right? Like this, Docker Hub. But from the Docker Desktop, you can directly access Docker Hub. So where you can search, pull and push Docker images to and from Docker's cloud registry. As you know, Docker Hub is a cloud-based registry service where Docker users can store, share and distribute Docker images, right? Next step, Docker Scout, which helps you find security issues in our Docker images, suggest ways to reduce the image size and also improve the overall performance of our images. Let's click on containers and here you can see terminal where we can write commands. Now suppose we want to check whether Docker is properly installed or not. We can write Docker command. You can see it will show you this output, right? Different commands of the Docker. So now we can say that our Docker is working properly, right? So this way we can write different commands as per our requirement in the terminal, which is directly provided within Docker Desktop that you can see. Let's close our terminal. So you can use terminal from here directly from Docker Desktop, right? But in our journey of Docker, we require main 4 things: containers, images, Docker Hub that we will use from here, Docker Hub like this, right? And the terminal, right? So we will use these 4 things: containers, images, Docker Hub and terminal. Hope all of you are clear with this, right? Now let's move on. I hope all of you have installed this Docker Desktop, right? So when you install Docker Desktop like this, it includes the Docker engine. So as I said, when you install Docker Desktop, it includes the Docker engine. The Docker engine is the core software that runs and manages containers, which has 2 main components. First, Docker daemon and Docker CLI, Docker command line interface. So Docker daemon is a background service that manages Docker containers on your system. It handles tasks like building, running, and monitoring containers and listens for the Docker API request. And another component, Docker CLI. The Docker CLI is the command line tool that allows you to communicate with the Docker daemon. You can use the CLI to issue commands like docker run, docker build, docker ps, etc. to control Docker containers and images, right? That I just showed you, right? We just wrote docker command, right, on the terminal. So together, these components allows you to create, manage, and interact with containers on your machine. So don't you worry, this is just for your information, right? When you install Docker Desktop, it includes Docker Engine, which is the core software that runs and manages containers, and which has two main components, Docker daemon and Docker CLI, right? Docker CLI, where we are writing commands. Using that, we can communicate with Docker daemon, right? So addition to the Docker daemon and Docker CLI, Docker Desktop also provides a graphical user interface, right? GUI, right? This GUI that you can see, where we can see containers and images, right? Also, we can write commands from here, from the terminal, right? So this GUI allows user to interact with Docker in a more visual and user-friendly manner that you can see, especially for those who prefer not to use the command line, right? Hope all of you are clear with this. Now let's move on. So before we move towards the practical part, let's understand Docker architecture. So first component, Docker client. So the Docker client is the primary user interface to Docker. It accepts commands such as docker run, docker build, and docker pull, which are then sent to the Docker engine for processing. It communicates, means Docker client communicate with Docker engine via Docker engine API, REST API. Now this is our second component, Docker engine. This is the core of Docker, responsible for creating and managing Docker containers. It contains two components, Docker daemon and REST API, that just we have discussed, right? As you know, Docker daemon is the server-side component that listens for API request and manages Docker objects like images and containers. We already discussed, right? REST API, Docker Engine API. Docker Engine API allows communication between the Docker client and Docker daemon. It is used by the Docker client to execute commands, right? So in our case, you can see that we have installed Docker, right? So these components, Docker client and Docker engine, these images and containers are available on our local machine, on our host machine, right? So this is host machine. And another component, Docker registry, right? That we discussed many times. And the most popular public registry is Docker Hub, which is available on cloud. And these all other components, Docker client, Docker engine, Docker daemon, images and containers are available on our host machine because we have installed Docker on our host machine. And this is cloud registry, right? From this cloud registry, we can push and pull images, Docker images, as per our requirement, right? Don't you worry, as I said earlier many times, we will discuss all this practically. Let me show you one more time, Docker registry. So as I said, this is the most popular public registry is Docker Hub, which contains many Docker images. So we can use images created by others, and also we can create and upload our Docker image on this Docker registry, right? On Docker Hub. I will show you this. So let's click over here, Docker Hub, and on Explore, you can see we can find many images created by other developers that you can see. So let's click on Docker official image. You can see these are Docker official images that anybody can use. You can see. Let me show you how to use this pre-built images. Let's click on this particular image, which is Docker official image. Let's click over here. This image for hello world. You can see. And this is example output. When we run this particular image that you can see, to use this particular image on our local machine, first we have to pull this particular image, Docker image, using following command, docker pull hello -world. Let's copy this. Let's move to our Docker desktop. I have already pulled this hello world Docker image. So let's remove this from my Docker desktop. Oh, first we have to delete container. So let's delete forever. So we have successfully deleted container for hello world. And now let's click on images and this one. Let's delete and delete forever. Now done. Now I am on my Docker desktop and on terminal. As you know, I have copied this command docker pool hello-world. Let's paste it over here. Let's press enter. You can see it is downloading latest image, docker image of hello world, and you can see here docker image that just we have downloaded, right? And you can see now we have pulled docker image from docker registry, right? Means from docker hub. Now let's move to docker hub, and now we have to run this particular image. So for that we have to use following command docker run hello-world, right? So first we have pulled this particular image from Docker Hub. Now this particular image is available on our Docker desktop, means on our local machine, on our host machine. Now we have to run this particular image. Now, as you know, when we will run this image, it will become Docker container, right? Running instance of Docker image. So let's run it. So Docker run hello-world. You can see exactly same output. Let's check on Docker Hub. You can see exactly same output. So we can say that we have successfully run our Docker image. So you can see the step. First, we have pulled this particular image, and then we run this particular image. So this image is directly available on Docker Hub, created by someone. So such many images are available that you can use in the same way that just we have used, right? Hello world image, which is Docker official image, right? This image. So let's pull another image, another Docker official image, getting -started, this particular image, which is again Docker official image. First, using this command, we have to pull Docker image to our local host, and you can see you can run it locally with the following command, this particular command, you can see. And then we have to open a browser at local host. Let's click over here, and we will see the output like this, right? So let's do this. First, we have to use this particular command to pull Docker image. Let's copy this. Let's move to our Docker desktop, and let's paste command over here. Docker pull docker getting started. Let's press enter. You can see it is pulling layer by layer because Docker image contains different layers. I will explain you, right? When we will create our own image, our own Docker image. Currently we are using pre-built images which are available on Docker Hub, which are created by others. Now you can see we have successfully pulled this particular image, docker getting started, right? Let's clear this. Now let's run this particular image. So for that we have to use following command, docker run, you can see -d -p, and here we have to use this port numbers 80 and 80, and you can see image name docker getting started, right? So you can see to run this image we have to use following command. Let's understand this. So first, docker run. So this command is used to run a container from a Docker image. The docker run command tells Docker to start a container from an image, right? And you can see -d flag. -d flag stands for detached mode. So when you add this tag, this container runs in the background, meaning it will not take over your terminal window. You will get your terminal prompt back right away. Next, -p. This part of the command is called port mapping. -p stands for publish, and it maps a port on your local machine to a port inside the Docker container, right? Don't you worry, just listen it carefully. You will understand it 100% when we will create our own image, right? So please remember -p stands for publish, and it maps a port on your local machine to a port inside the Docker container. As I said, you will understand it better when we will create our image. And 80, this first port number is the port on our local machine, and another port after colon, the port inside the container where the application is running, right? So this is local port of our local machine, and this is port inside the container where the application is running. This means that when you access this local host at port number 80 in our web browser, Docker will forward the request to port 80 inside the container. So now let's move over here to our Docker desktop and let's press enter. Now let's move over here and localhost 80, and you can see here getting started page, right, which is running from our local machine because we have downloaded this image getting started and also we run this particular image, right? So now you can see we have successfully pulled the image from Docker hub to our Docker desktop, means to our host machine, and also we run it as a Docker container. Hope all of you are clear with this, right? How to use Docker images created by other, right? But now it's time to create our own image. So as you know, we have completed this scenario. We have pulled images from Docker registry, means from Docker hub, to our host machine, and also we run these images as a container, right? Now we are going to consider this particular scenario where we are going to create a Docker image, and also at the end we will push this particular image to Docker registry. So anyone can use our created Docker image and run as Docker container, right? So let's do this. We are going to create our own Docker image. So to create our own image, imagine this particular scenario. We have built a simple Python application and we want to Dockerize it so it runs anywhere, right? So let's open command prompt. Let's move to E drive. Let's create new directory with name docker-test. Let's move inside this particular directory and let's open VS Code from here, right? You can see. Now let's create new Python file. You can give any other name as well. I'm giving kelsey.py, and you can see I have created a very simple Python code that performs addition of two numbers, nothing else, right? Let's save this file. So we want to Dockerize this particular application so it runs anywhere without any problem. So this is our first file, our application file, which contains code for our application, kelsey.py. Another, and we require requirements.txt. At this time, there is no any dependencies for this app. So let's just write comment inside requirements.txt. No dependencies for this app. I will take another example where we have to include some libraries as dependencies. But currently for this simple application, we don't have any dependencies, right? So for that, I'm just writing this particular comment. Now let's create very important file, Docker file, right? So as you know, a Docker file contains different layers or different steps. When we build it, it creates a Docker image. When we run Docker image, it becomes Docker containers, right? So this is the flow. So you can see this is our application, addition of two numbers, and we have created this particular file, requirements.txt. Now we are going to create Docker file. So when we build Docker file, it creates a Docker image. When we run Docker image, it creates Docker container, right? As you know, Docker container, it's a running instance of Docker image, right? So we are going to perform this particular flow. We have already created this particular application. Also, we have created requirements.txt. Now we are going to create this particular file, Docker file. Then after, we will build this particular Docker file with Docker build command. So it creates a Docker image. When we run Docker run command, it creates Docker container. As I said earlier many times, Docker container, which is running instance of Docker image. I hope now you can understand everything, right? So now let's create this particular file, Docker file. A Docker file contains different layers or steps that helps to build Docker image. The first layer is base image. Second, we have to set the working directory in the container. Next, we have to copy the current directory contents into the container at this particular folder, app. Next, we have to install any needed dependencies, and here we have to write command to run the application. So for this particular code, we require this many steps inside Docker file. Let's save this. So to create base image, we have to write from Python colon 3.9 and slim. Let's save this. So it specifies the base image for the container, which is a minimal version of Python 3.9 slim. This ensures your container has Python installed without unnecessary extras and keeping the image small in size. Right? Now next, here we have to set up the working directory in the container. For that, we have to write command like this, work dir, right? And here I'm using app. Let's save this. So this command sets the working directory inside the container to app. So please remember any subsequent commands that we will use like copy, run and cmd use this particular directory as their base, right? Next, here we have to copy the current directory contents into the container at this particular directory that we have set over here. We have to write copy dot app. So here this command copies all the files from our current directory where the Docker file is located into this particular directory app inside the container, right? So this includes our Python script, requirements.txt and other files if we have, right? This command copy the current directory contents into the container at this particular folder that we have created over here, right? So here in the next layer, we have to install any needed dependencies. But as you know, we don't have, but still let's use this run command and pip install requirements.txt. Also here we have to use -r, right? And next we have to write command to run the application. So for that we have to use cmd, and here you can see Python command and /kelsey.py. So this way we can create different layers for our Docker file. So here we have set the base image for the container. Here we have set the working directory inside the container. After that we have copied the current directory contents into the container at this particular app, right? Here we copy the content from our current directory into the directory available inside the container, right? This particular app that we have created over here. After that, here we are installing dependencies and then we are running our application, right? As simple as that. Let's save this. Let's open new terminal. So let's run this application without container first, just for checking, right? So how to run Python application? Using Python and file name kelsey.py. You can see 30 without container, right? Like a normal Python file. Let's clear this. We have completed this. We have created an application. Also we have created requirements.txt. Also we have created Docker file. Now we have to write this particular command, docker build, to build Docker image. Let's do this. For that we have to write docker build -t, and here you can give any name. Let's give Kelsey and dot, right? So this is command docker build to build new image from a Docker file. -t. This flag is used to tag the Docker image with a name. You can give any other name. I have given Kelsey. You can give any other name, right? And here is the dot. Here this dot represents the build context, which in this case is the current directory. That's why here we are giving dot. Let's press enter. You can give building started and it will build Docker image stage by stage as per this Docker file, one by one, right? This is the first stage, then second stage, then third stage, then fourth stage, and this is the final stage, right? So you can see now it is building Docker image from the Docker file that we have created over here. You can see we have to wait. It will take some time. Now done. You can see we have successfully built our Docker image. Let's check on Docker desktop. Also, let's clear this. And here also you can write Docker images command. You can see this is our image. By default tag is latest, which is created 22 seconds ago, right? That also we can check different images using following command, Docker images. Now let's check on Docker desktop. Let's reload this and you can see here image just we have created from our Docker file. You can see. Now let's run this particular image to form a container. right? Then it will show you container over here, right? Move over here. Let's clear this. So again, we have created our application, addition of two numbers. Also, we have created requirements.txt. Just we have created Docker file with different layers, means with different steps. Now just we build Docker file and created Docker image. Now we are going to run this particular Docker image that just we have created, which creates Docker container. Please remember, we have created this Docker image locally on our local host, right? It's our responsibility to push on the Docker hub, means on the Docker registry if we want, right? So anyone can use it. We will do this shortly, but just we are going to run Docker image to create Docker container. Let's do this. So for that, we have to write following command: docker run -i, our image name Kelsey. Let's press enter. You can see we are running our container, which is created from our Docker image. Let's enter 10.2 and 30.2. Can you see the result? 40.4. So this is command docker run. This tells Docker to start a container using the specified image, this particular image that just we have created, right? Kelsey. Here I am using -i. This makes the container interactive, means keeps the container running and ready to accept your input like this. That's why here we are using -i to make the container interactive, right? Let's move to Docker desktop and here let's check inside the container. You can see we form a container from this particular image that you can see. Hope all of you are clear with this, right? So we have followed these particular steps. We have created an application. Also we have created requirements.txt. Just we have created Docker file. We built Docker image from the Docker file. Also we run Docker image to form Docker container. Hope all of you are clear with this, right? So you can see we have created this particular container, which is currently available locally on our computer. But suppose we want to share it with others. In that case, we need to push the Docker image to Docker Hub, which we are going to do next. So we will push this particular Docker image to Docker Hub. So anyone can pull the image and run it as a Docker container, right? To do this, we have to first write following command: docker login. Done. And you can see also here I have logged in on the Docker desktop with my Gmail account. You can see same way. Let's open Docker Hub from here. And also I have used same login on the Docker Hub as well. So that's why this particular command is working for me, docker login, right? If you are doing for the first time, it will tell you to authenticate, right? That you have to complete. Then you will get this particular message: login succeed. Now let's push our image, docker push. And please remember, we can't directly push this particular image, right? Anyhow, we have to make it unique. So for that, let's create tag Kelsey and my user name data thinkers, that you can see here on the Docker Hub. You can see data thinkers, and we have to push image like this: username and image name, username and image name. That will make it unique by default, right? On the Docker Hub, data thinkers / image name, data thinkers / image name, right? Data thinkers / add -numbers. Let's press enter. Sorry, first we have to tag only, then we will push it. Sorry for this, right? Docker tag Kelsey, and this is our image that we are going to push on the Docker Hub, so anyone can use it. Let's press enter. Done. You can see we have successfully created this particular image. You can see we are currently in the images tag, data thinkers / add -numbers. Now let's push it. Docker push data thinkers / image name, and also we can add any tag, latest, so other can identify this is the latest image, right? So let's press enter. You can see it is pushing layers by layers, right? That we have created earlier. So we have to wait. It will take some time. Once it's done, you can see over here on my repositories, Please wait, it will take some time. Now done. Let's move to Docker Hub. Let's click over here. Let's move to my profile, and you can see here data thinkers / add hyphen numbers. You can see updated a few seconds ago, and these are my previously uploaded images, right? And this is the current image that just we have uploaded, right, on Docker Hub. So now anyone can use it, right? Also you can try to pull this image, and also you can run it as a Docker, right? Let me show you this. Let's click over here, and you can see Docker pull command. Let's copy this. Let's move to Docker desktop, and first let's remove this. Let's remove this container first, and also let's remove this. Now all done. Let's clear this, and let's pull our image that just we have uploaded on Docker Hub. Let's press enter. Now you can see this particular image, right, that we have pulled from Docker Hub. So now let's run it as Docker container. So for that we have to write Docker run -i data thinkers / add hyphen numbers. Let's press enter, and you can see the output, right? So just we have pulled our created image from the Docker Hub, and we run it as a container. Try to pull this particular image that just we have created and run it as a Docker container on your local machine. I hope all of you are clear with this, right? How to build a Docker image. Again, we have completed this particular flow. We have created an application. Also, we have created requirements.txt. Also, just we wrote Docker file from scratch. We built Docker image from Docker file. Also, we run Docker image to create Docker container, right? And also we have pushed this Docker image to Docker Hub, to Docker registry. After that, also we have pulled the Docker image from the Docker Hub, and also we run Docker image as Docker container. Hope all of you are clear with this, right? Entire flow of Docker. Now let's move on. Let's take another example. So you can see that we have Dockerized a simple Python application for the addition of two numbers. Now let's move on, and let's Dockerize a Flask app for the same functionality, addition of two numbers, right? So let's open command prompt. Let's move to D drive. Let's create new directory, Docker_Flask. You can give any other name as well. Let's move inside this directory, and let's open VS Code from here. First, let's create app.py, our Flask app. You can see I have created a very simple Flask app for addition of two numbers. Let's save this. Let's open new terminal, and first let's run it locally. Let's follow this link. You can see this is very simple app that I have created using Flask. You can see. Now let's Dockerize it, right? For that we have to create one file, requirements.txt, and this time we required Flask, right? Let's save this, and we have to create a very important file, Docker file. And you might have observed we are creating Docker file without any extension, right? And here we have to provide different layers, base, image from Python 3.9-slim. Our first step, then we have to set working directory in the container. So for that we have to use following command, and let's create directory with name app inside the container. Now we have to copy the current directory contents into the container at this particular directory, right? That will be created from here. For that we have to write copy source current directory and destination this particular directory which is available inside our container. Now here we have to install any required dependencies or called as packages. So run pip install -r requirements.txt. Then here very important step that is new inside this application, because we are creating Flask application, right? And we can see the output on the browser. So we have to expose the port. So for that we have to write expose and port number 5000. And here we have to run our app. So command, and we have to run like this python./app.py. Let's save this file, right? So we have created our Docker file. So as per our flow that we are following, we have completed these particular steps. We have created our Flask application. We have created requirements.txt. Just we have created Docker file. Now we build Docker file to create Docker image, and we will run Docker image to create Docker container, right? So let's build Docker file that will create Docker image. Let's stop this. Let's clear this. Docker build -t for tag Flask addition app. You can give any other name as well, and dot. As you know, this command docker build builds the Docker image -t, tags the image with the name Flask addition app and dot, which specifies the current directory as the build context. That's why here is dot. Let's press enter. You can see Docker image building process has been started. You can see. Now I think all done. Let's check using command docker images. As you can see, this new image has been created. Let's check on Docker desktop. You can see here this new image has been created. Now let's run the Docker container. So let's clear this. So we have to run like this: Docker run -d -p. Here host port and port available inside Docker that we have exposed over here, and our image name Flask addition app, right? So here we have used this particular flag -d runs the container in the detached mode, and here -p maps 5000 port on the host to the port 5000 in the container that you can see we have exposed over here, and our app name. Let's press enter. You can see done. Let's open the browser. Let's press enter. You can see our app is running. Let's press add. You can see all done. We can say that we have successfully containerized our Flask application, right? Now this way you can containerize any Flask application that you have. Let's move to the containers, and you can see here our container, right? And as you know, optionally we can push our Docker image to Docker Hub, so anyone can use it. Let's do this. So for that, first we have to write Docker, and we have to tag the image Flask addition app to my user name data thinkers / Flask addition app. Let's press enter. Done. Now we have to write Docker push data thinkers / Flask addition app. Let's press enter. Process has been started. You can see we have to wait. It will take some time. Now done. Let's check on Docker Hub. Let's refresh this page. You can see here we have successfully uploaded our Docker image on the Docker Hub. Now anyone can use it. Please try to pull this image and try to run it as a Docker container, right? You can search with this data thinkers Flask addition app, and you will find this right on the Docker Hub. Hope all of you are clear with this, how to Dockerize any Flask application. Let's move on. You can see that we have successfully Dockerized our Flask application, right? And please don't forget to run app with this host 0.0.0.0, right? Otherwise it will not work. Please remember this. Now let's move on and let's try to Dockerize FastAPI app. So again, let's open command prompt. Let's move to D drive. Let's create new directory docker_FastAPI. Let's press enter. Let's move inside directory and let's open VS Code from here. Now let's create new file with name app.py. You can see I have created a very simple FastAPI app that will print hello world. Let's save this file and let me show you how to run locally first before we Dockerize it, right? So first we have to install FastAPI. As you can see, in my case, requirements are already satisfied. Let's clear this, and to run this we have to use following command: uvcon main :app. Here main, which is app name, so I think let's change it to main, otherwise it will create confusion, right? So app, which is app name, colon app, which is FastAPI instance, right? Hyphen host 0.0.0.0, and also we can specify port number 8000. Let's press enter. Let's check on the browser. Port number 8000. Let's press enter. You can see we can run our app successfully, right? Let's close this. Let's clear this. Now let's Dockerize our FastAPI app. So for that, as you know, we have to create requirements.txt first. And here we require two dependencies to be installed, FastAPI and UV-con. Let's save this. And now let's create very important file, Docker file. Here I have created Docker file exactly same way as we are creating since long, right? Base image, set the working directory inside the container with name app, copy the application code into the container. You can see, install the dependencies. Here, expose the port on which the app runs and command to run our application, our FastAPI application, right? Now let's first build the Docker image from this Docker file. So as you know, for that we have to write Docker build -t FastAPI -hello-world. Let's press enter. Also here we have to provide this dot, right, which specifies the current directory as the build context. Sorry for this. Let's press enter. You can see process has been started, and you can see we are at this particular step. All done. Let's clear this. Let's check images with this command, and you can see we have successfully built Docker image for FastAPI. Let's clear this. Let's check here as well. You can see our Docker image. Now let's run our container. For that we have to write Docker run -d -p host port, container port, and our app name FastAPI -hello-world. Let's press enter. Now done. Let's check, and you can see our app is running successfully, right? Let's check inside the Docker desktop, and you can see our container. Now let's push the Docker image to Docker Hub, which is optional, right? But let's do this. So first we have to tag our image FastAPI -hello-world data thinkers / FastAPI -hello-world. Let's press enter. Done. Now let's push this image to Docker Hub FastAPI -hello-world. Let's press enter. You can see the process has been started. Let's move to Docker Hub, refresh this. Let's move to my profile, and you can see over here we have successfully uploaded this particular image on the Docker Hub that you can see FastAPI -hello-world. Try to pull and run this as a container right from here. So you can see we have successfully Dockerized our FastAPI app. So this way you can Dockerize any FastAPI app if you have. Let's move on. You can see we have Dockerized simple Python application, also Flask application, and also FastAPI application. Now let's move on. Now we want to Dockerize a Streamlit application, right? So again, let's open command prompt. Let's move to D drive. Let's create new directory Docker_Streamlit. Let's press enter. Let's move inside this folder Docker_Streamlit, and let's open VS Code from here. Let's create new file with name app.py, and as you can see, a very simple Streamlit app with title and this write function, nothing else, right? Let's try to run it first locally. Streamlit run app.py. Let's press enter, and you can see our app is running properly, right? Let's close this and let's terminate this process. Let's press Ctrl C. As you know, we have to create requirements.txt, and here we required Streamlit as a dependency, right? Next, as you know, we have to create a very important file, Docker file, and you can see here I have created Docker file exactly same way as we have created earlier. Base image, set the working directory inside the container with name app, and here copy the application code and requirements file into the container, right? Means all from the current directory to this particular directory. that we have created over here inside the container. Here we are installing the dependencies, right? Again, here we expose the port 8501 and command to run Streamlit app. Streamlit run app.py, port and address, right? Hope all of you are clear with this, right? So first we have to build the Docker image, right? So for that we have to write Docker build -t Streamlit -hello -world. You can write any other name as well. And current context dot, right? Let's press enter. You can see Docker image building process has been started, that you can see here. We have to wait, it will take some time. You can see it is installing Streamlit that we have mentioned inside requirements.txt, that you can see. It will take some time, we have to wait. Now done, you can see exporting to image and exporting layers. Now done. Let's clear this and let's check. And you can see here, we have successfully built Docker image from Docker file. Let's check here on Docker desktop as well, image, and you can see here Streamlit -hello -world. Now let's clear this and let's run the Docker container. So Docker run -b -p host port, container port, and app name Streamlit -hello -world. Let's press enter. Done. Let's check here 8501. And you can see here our app is running successfully, right? Through our container. Now let's push this Docker image over here as well on Docker Hub. For that, first we have to create tag Docker tag Streamlit -hello -world to data thinkers Streamlit -hello -app. Let's press enter. Done. And also first let's check this Docker login succeed. You can see authenticating with Docker Hub. Done. Now Docker push data thinkers / Streamlit -hello -app. Let's press enter. You can see the process has been started and it is uploading Docker image to Docker Hub. Here, so refresh this. We have to wait. It will take some time. Still it is running. It will take some time. We have to wait. Now done. Let's check over here. Let's reload this page and you can see here Docker image for our Streamlit application, right? So you can see we have created these many Docker images which are available on Docker Hub. Just you have to search data thinkers and try to pull in your computer and run it as a container, right? And also try to containerize your app. If you do this, put your image path in the comment section of this video. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.